We now continue with our video series on generic arrays. Now, you understand from part 1, you understood why you want to do it. You want to write a separate class, that's a wrapper class for an array, meaning you can store any array of any class there, and you can make it, you can add functionality not in the standard Java array. It's like extending the language Java. Now, I think you figured out from the previous part that when you write that program, you do not know whether it will be phone listings, cell users, or what any type of objects will be stored. So you have to write it in such a way to handle all possible objects in there. Now, there are 3 problems associated with this process of writing independent programs. The first one is when we assign A equals B, when A is of type T. We will talk about this just now. The other one is to execute the toString method. And the third one is if we compare two objects of type T in an if statement, then we have a problem. But we will tackle all of these one at a time. The better you understand one before you go on to the next one, the bigger your probability of understanding it very well. Before we talk about A equals B in general, in generics, I want to refresh your memory on a shallow copy and deep copy. If I have a class, let's say it's cell user. If I say cell user, let's make a C1 and a C2. If I say cell user C1 equals new cell user, and I gave him a name and a number. Let's say this is how this class is defined, and C2 equals new cell user John. Nice short cell numbers, these. Okay, you know that C1 is an address. C1 is stored at a specific memory position. So we can say that C1 contains an address like 100. You also know that C2 contains perhaps another address depending on the size of the object. Let's say 400. Where did these addresses came from? The new operator returned it. So this line C1 equals new cell user really tells the constructor, go to the computer memory, find a place for a new object, call it C1, and store in it the values for the attributes, and bring back the address where you stored it so that I can get it again. And that is what C1 is. It's the address of a new object. So if I say, let's play around with this code. If I say C1 equals C2, and I say C2.setName, let's say cell user had a nice accessor method, mutator method, set name, and I say C2 is no longer John, it is now Sue, C2. If I say now C1 get name, and let's just assign it to S, and I say what is in S? What would you say? Most of you would say Pete. Is it Pete? No. It is Sue. The question is why. And the answer is the definition of shallow copy. What happens when you read this line here, or this one? All of them works the same. You tell the computer, go to a specific memory position, go to the position stored in C2. Before we did this line, it would be 400. Go to line position 400, go and change the name to Sue. So let's see what we have done here. We had two separate memory positions, but now we've taken C2's position and we assigned it to C1. So that one is now 400 and this one is 400. So now we tell the computer, go to C2. C2 is 400. Go to that position and change the name there to Sue. So in memory, at position 400, there's a name, and a number. And we had the name John there, and we replaced it with Sue. We had the number 456 there. So we said go to position C2, what is it to? Change the name there to Sue. Now, in this line, we say go to position C1. What is C1? Oh, it's 400. Get the name there, it's Sue. Return it to S, store it in S, and say what is S. And it is Sue. This is shallow copy. If I wanted to have two independent objects going their own way, separate ways, I had to do something like C2.setName if I wanted to do the name, and then say C1.getName. Sorry. Let's just pick up there. Delete that a little bit if I can get it running. No, I can't. C1.getName. Sorry let me just rewrite that. So to change the name of C2, I would say C2 setName. What should I set it to? C1 getName. So I would have to change the separate fields of these objects to make sure that I do not lose the memory position. The moment I use the object as a whole, I have a problem with shallow copying, that I'm losing some of the objects. You would notice that this position 200 or position 100, where C1 was stored, is now totally lost. I don't have a reference to that any longer. Okay, so now you understand the difference, the problem. We can have a look at detail. As I said, if I say A equals B, it changes A to point to the same address as B. So I've done bullet 2 for you. I explained the difference between deep and shallow copy. So one has to do a deep copy. But you cannot add a deep copy to a method in an object in a generic class. It simply doesn't work. Now, the textbook you have has a workaround. It works with a key mode interface. But I think it's much easier is to just make sure that you know this difference and that you do all your deep copy in the test program. So you have two options. Option 1 is to go the key mode route. That is an interface, and you add into that interface a deep copy. And all the classes who wants to use your data structure or your array, your new data structure class, must implement key mode. Now that's too difficult. It makes it too cumbersome to use it. It's possible, but I prefer to do all the deep copy in the driver to know about this problem in generics and to sort of make sure I don't get into the problem in the class. So I prefer to do option 2. To me it's easier. Okay, now if you understand that we cannot copy field by field in the generic class, you will understand the problem with toString. Let me say something shortly about that. One cannot copy, you know that if you say A plus B, A equals B in a generic class, it's a shallow copy. Then the idea was to add or to copy it with all the instance variables. But you don't know when you write the program what the instance variables are. When I write the program for the unsorted optimized array, I did not know the listing classes attributes, neither the cell user class. But I do not want to know those attributes. I cannot specify attributes for objects I don't know. So the idea is to write a toString is rather difficult. A toString normally is a method that displays attributes, and now I don't know the attributes because I don't know which method will use this generic class for which type of objects. Now the easiest way is to add to say that any class that wants to make use of our generic class must contain its own toString class, and the toString method of that class will then be executed. So in our toString in the array class, we simply call the toString class of the client class, and then that client class will be executed. Now this is a brilliant example of polymorphism. This is where the triangle brackets come in. Java is fancy enough to know that the class that is in those brackets is using it and is using this array at the moment, and that class's method will be executed. Okay, we will do a complete example of this later on in part 4.